Hey guys, today we're taking a look at organizing data into two-way tables. Two-way table is a frequency table that displays data collected from one source that contains information about two different categories. One category is represented by the rows and the other is represented by the columns. Here's an example of a two-way table that collected data from freshmen and sophomores responding to the question, "Have you ridden an electric bicycle?" So you can see here these inside frequencies. These are known as the joint frequencies. And your categories are ridden a bicycle or the class who's responding to that. All right, next up is a term known as the marginal frequencies. Now the marginal frequencies is just the sum of the rows and the columns. So when we add 13 to 62, we're going to end up with 75. And then when we add 21 to 56, we're going to end up with 77. So there were 77 sophomores who responded to this survey and 75 freshmen. When we add the columns down, we'll add the 13 to the 21, which will give us 34, and then 62 to the 56, which will give us 118. So in all, there are 118 freshmen and sophomores who have not ridden an electric bicycle, and there were 34 freshmen and sophomores who have. Now down here in the lower right-hand corner, which you'll see in just a minute, is the sum of those marginal frequencies. And that's going to be the total number of people who responded to this survey. And that's what we're asked to do here in example 1. Find and interpret the marginal frequencies. Then add the entries in each row and column. So we just added those together and got 75 and 77. Now when we interpret that, we must attach the label here of the type of response this is. So we'd say there are 75 freshmen who answered the survey. Okay, there were 77 sophomores who answered the survey. Okay, likewise, when we add down, we said that we came up with 34 who have ridden an electric bike, and then 118. Now, all in total, there were 152 total people who responded. All right, so you can see here sophomores and freshmen, and then when we interpret the marginal frequencies here, we say that there are 34 who have ridden, and we're going to abbreviate that as an electric bike EB, and there are 118 freshmen and sophomores who have not ridden. All right, now I'm kind of abbreviating here for the sake of the time of our notes, but you're going to want to make sure that you write down as much as possible when it comes to interpreting what those marginal frequencies represent. All right, let's move on to our next example. Example 2 says, make a two-way table based off this information. You're going to conduct a survey that asks 286 students in your class whether they play a sport or a musical instrument. So that 286 is important. That's going to be this bottom lower right-hand corner. That's the total number of people that we surveyed. 118 of those students play a sport, and 64 of those 118 play an instrument. So that 118 is going to come right here in the total that play a sport. In other words, they answered yes to playing a sport. The 64 of those 118 play an instrument. So that's going to go in that first row, first column. They play both a sport and an instrument. So that's the yes, yes entry. All right. Next up, we have 93 students do not play a sport or an instrument. So that 93 is going to come down here in the no column. Now, it looks like we have a pretty incomplete chart, but remember, these all sum across and down. So we can find the missing elements simply by doing some subtraction. When I take 286, my total, minus 118, I'm going to end up with 168. Now that means there are 168 that do not play a sport. Likewise, if we move across from right to left, I know that this sum of this row should add up to be 168. So if I take 168 and subtract 93, the students that don't play a sport or an instrument, then I will end up with 75. And that's the number that do play an instrument but don't play a sport. Likewise up here, we're going to get 54, and now we can add down our columns to get 147 out of our 286 that don't play an instrument, and then 139 do play an instrument. All right, so that's just filling out a two-way table, given some of the information. Do be careful as you read through and make sure you pick out things like 118 of the students that play sport and 64 of those students. That means 64 out of the 118. All right, moving on, we get a few more new terms. So this next term here is called the joint relative frequency. Now, the new word in here is relative, and what that really means is we're going to create a ratio, and you can see that it's a ratio of the joint frequencies, which are the numbers inside the boxes, to the total number of values, and that's that lower right hand corner's number. Okay, the marginal relative frequencies is the sum of the joint relative frequencies in the row or column. So let's do an example here. Example 3 says the two-way table shows the results of a survey that asked college-bound high school students whether they plan to major in a medical field. Make the two-way table that shows the joint and marginal relative frequencies. So make sure you pay attention to that word relative, because that means we need to know the total number of people that responded to this survey. So one way to get that is we're going to add our rows across, and when we add those rows, we're going to have 343 juniors, and there were 337 seniors. Now to get the total number of responders, we're just going to add those two rows down, and that's going to give us 680. So there were a total of 680 responders to this survey. To find the joint relative frequencies, we're going to take each one of these joint frequencies here, and we're going to divide them by 680. And that's going to be our entry into these buckets over here. So let's do that now. I'm going to erase this. Let's take 124 and divide it by 680. When we do that, we get 0.18. Okay, next up, let's take the juniors that are not planning on a medical field. That's 219 divided by 680. When we do that, we're going to get 0.32. Next up, we'll take our seniors and divide that by 680. So that's 101 over 680, which is going to give me 0.15. And finally, our 236 divided by 680, and that will give me 0.35. All right. There's our joint relative frequencies. Next, we're going to find our marginal relative frequencies by adding our rows across. When we take 0.18 and 0.32, we get 0.5. In other words, 50% of the responders, or approximately 50% of the responders, were juniors. And then when we take our 0.15 and 0.35, we'll get another approximately 50%. And now keep in mind, these should add down to equal 1. In other words, 100% of your responders. Next, we'll find our marginal relative frequencies of the columns. So we'll add down 0.18, 0.15 gives me 0.33. And we're just going to continue this little line here. And then we got 0.32 plus 0.35, and that gives me 0.67. And again, your marginal relative frequencies in that bottom row should add across to equal 1 as well. Okay, so there are your joint and marginal relative frequencies. Remember, you need to know that total value or that total number of responders in your survey, and you're going to divide each of the joint frequencies by that total. All right, our next up is conditional relative frequencies. So now we get, again, a new word here. Here's conditional relative frequencies. You know that that's just the ratio. So conditional relative frequencies is the ratio of the joint relative frequencies to the marginal relative frequencies. And it says you can find a conditional relative frequency using either the row or the column totals. So above in our previous example here, we had our marginal our conditional relative frequencies are these numbers up here in these boxes, and our marginal relative frequencies were our totals in the column and these rows. Okay, so what we're going to do is we're going to create a ratio between our yellow highlighted numbers and our totals in the column. So for example 4, it says to use the survey results in the previous example to make a two-way table of the conditional relative frequencies based on the column totals. All right, so we're going to take each one of these little numbers up here, 0.18, and we're going to divide it by the column totals. So we'll take 0.18 and divide it by 0.33. And when we do that, 0.18 divided by 0.33, we'll get 0.55. All right, next up, we're going to move across to the next row here. Actually, let's move down the column, stay in the same column. We're going to take 0.15 and divide it by 0.33. When we do that, we get 0.45. Now, hopefully you guys are checking this on your calculator. Don't just follow me along. Make sure this actually does check out. All right, next we're going to do the no column here. So finding our conditional relative frequencies, we're going to take the joint relative frequency, 0.32, and divide it by the column's marginal relative frequency of 0.67. When we do 0.32 divided by 0.67, we get 0.48. And then finally, 0.32 divided by 0.67 is going to give us 0.52. All right, now these conditional relative frequencies help us find associations. Association just really kind of talks about if there's a relationship or a correlation between variables. All right, so in example 5, we want to learn to recognize associations in our data. It says you survey students and find that 40% of the students you surveyed exercise regularly. Now that 40% means it's going to go in this total column of exercise regularly. So let's put 40% here. Next it says 35% it should say eat fruit and vegetables each day. So 35% are in this yes row. Okay? And 52% do not exercise and do not eat fruits and vegetables. So that goes in the no column. No for exercise and veggies. All right, is there an association between exercising regularly and eating fruits and vegetables? So that's going to be our end goal here, to figure out if there's an association between exercising regularly and eating fruits and vegetables. So let's finish filling out this two-way table of frequencies here. So remember, this lower right-hand corner should add up to equal 100%, all of your responders, which means we can figure out the remaining boxes here by doing subtraction. 100 minus 35% is going to give me 65%. This 40% minus 100% should give me 60%. All right, so we're going to continue to do our subtraction upward through this column and across for these rows here. So this should give me 27% that do eat regularly vegetables and exercise regularly. And then finally we should have 13% here. All right, now in order to find an association, we are going to use conditional relative frequencies. And we're going to find those conditional relative frequencies by, remember, taking those joint frequencies and dividing them by, or creating a ratio with them by their column totals. Okay. So this one says, is there association between exercising regularly? So there's exercising regularly is yes, and eating fruits and vegetables. So that's also eating fruits and vegetables here as well, okay, but not exercising regularly. So in other words, we're going to take our 27% out of the 40% and find that conditional relative frequency, and we're going to compare that to the 8% that don't exercise regularly but do eat fruits and vegetables. Okay, we're going to compare it to this conditional relative frequency. So when we do that, we get 27 divided by 40 is about 67.5%. All right, so in other words, those that do exercise regularly and eat fruits and vegetables, about 67.5% of them, compared to the 8% divided by 60%, which comes out to be about 13.3%. All right, so that's quite a bit less that eat vegetables regularly but don't exercise. So we're going to say, yes, there appears to be an association between exercising regularly and eating vegetables. Alrighty guys, we'll save that last example in your notes for in class.